Today we are looking at fine tuning on Azure, and this is with respect to the set of models that can be fine tuned on Azure. Now, typically, all of us have heard this term called RAG, Retrieval Augmented Generation, where you're augmenting the context of the model with your information related to your domain and your data set. You retrieve that information, you give that to the model, you augment the context of the model, and then you generate the outcome. So that is typically the methodology in which we have been making the LLMs work on our data. Now, one of the challenges with that approach is it is a bit time consuming. Also, the number of tokens that get exchanged because of the specific instructions that get passed in every prompt, that adds to the bulk of the request, and needless to say also adds to the tokens. It could also introduce latency issues. It could also bring in accuracy issues. Now, let's say, for example, I have a very specific domain, I have niche data set that I have to work with, and I want to bring in that data set to fine tune my large language model and get a deployed version of that fine tuned model. So, that is where a pre trained model can be taken. It can be customized with my own curated data set, and behind the scenes the modification of the model happens, and then I get a fine-tuned model, and I'll be able to deploy that fine-tuned model on the Azure infrastructure. When it comes to Azure OpenAI, the set of models that have been opened up for fine-tuning, they use a technique called LoRA, which is low rank approximation, in which only a specific set of interested parameters of the model are modified. And because of this, the complexity of fine tuning is reduced without compromising anything on the accuracy and the performance, and making this more faster and more affordable. So that is the technique that's used on the Azure platform. Now, when do you apply fine tuning and when do you not, right? Because most of the times people who come from a traditional ML background almost always ask this question, how do I train my model? Whereas in the context of large language models, there's nothing like a trained model because it takes humongous amount of resources, CPU cycles, GPU cycles, as well as very well curated data sets in order to grounds up train a large language model. So that is a very tedious task, and it's also heavy on the pocket. So rather, for most of the use cases that we have seen with customers, predominantly prompt engineering and RAG work for almost 90% of the use cases. If it's a very niche industry, let's say pharma or energy, or let's say legal, or any specific domain use case related industry for that matter, that's when the fine tuning is actually applicable. In fact, if you look, there are other techniques such as model distillation, etc. But today we will look at only fine tuning. Now, mostly the language models, the way typically we work without fine tuning is we engineer the prompt that is given to the model. We have a few short or zero shot or one shot examples that is given to the model, and with that, the model actually performs. Here, none of the parameters are tweaked or none of the weights of the model is actually tweaked. But every time you need to pass this context to the model in terms of the prompts, and that is basically time consuming. Now, rather, I eliminate that entire step. I give curated data set and I give a training data set and I give a validation data set. I train or fine tune the model with that particular data set, and my fine tuned LLM is now available for the changes in the parameters, and then thereby I'll be able to use a deployed version of the fine tuned model. So I'm now on the Azure AI Foundry, and I can see the model catalog, and in the model catalog I can see which are those models where I can do fine tuning on the Azure platform, and there's a bunch of models which are there directly from OpenAI as well as from other providers as well. So in this case, I pick up GPT-4o for fine tuning, and once I pick up this model, I can basically look at this option called fine tune. So this is the base model card of the model. It gives more details about the original model itself. So we are taking this raw model, and then we are going to go ahead and do a customization of this particular model. So when I go into the model fine tuning, I pick up this base version, and here we are applying supervised fine tuning. The model, I will give it as a prefix as medical test, for example. This is my suffix that I'm giving to the model. That's basically to denote my version of the fine-tuned model. Then I just pick up the Azure AI resource. Now I have two ways to give in training data. I can upload the training data to Azure AI Foundry and pick it from there, or I can just upload the files here. So in this case, what I've done is I have data in Azure AI Foundry, which I've uploaded in the past, and I can pick up, let's say, the training data set that I've given to the model. If I'm not doing this, what I could actually do is I can use the upload file option, use the files, and use the training data.json, and this basically gets uploaded into the Azure AI in the data section. Now that I've already done that, I can basically go ahead and get the data set right from there. So I'm just picking up the data from Azure AI Foundry. I'm picking up the training data set. It also does a validation of the training data set. If there is something wrong in the JSON format or the format of the training data set, it gets rejected. So let me just give you a quick look of what the training data set looks like. It has to be a JSON-L format, which means that the entire object falls in one line. And also, you need to have a minimum of at least 10 such objects. Of course, in a real production scenario, you will have much more data sets that have gone in. It needs to end with a UTF-8 bomb encoding. That is a mandatory requirement for the format of the data set. Now I have a similar training data set. I have a validation data set. I go back to the fine tuning task, and I've given the training data set. I can choose the validation data set as well. So I've picked up the validation data set. Now I do next. I would basically retain these defaults for now, and all I need to do is submit this job. The moment this job is submitted, you can see that the job is queued, and this particular model is out there for fine tuning. It takes a while for a particular scheduler to pick this provision and infrastructure behind the scene and fine tune this model. So I have done that already now, and I have got a fine tuned version of this particular model. Now you can see that number of epochs that it completed is 5, batch size is 1, and the training completed on its own. So it took about 3 hours to fine tune this model, and I have the fine tuned model over here. Now what I can do is I can go ahead and deploy this model, and when I say deploy this model, I can, just like the way I would deploy any other raw model, I can pick up this fine-tuned model and I can deploy this model, and this is available for me on the Azure portal. Now what I've done is I've actually done a deployment on the chat playground, and I can say either use the GPT-4o, which is a plain vanilla version of the model, or use the fine-tuned version of the model, and with that I'll be able to use this particular version of the model. I can even further continually fine tune this further. In case I'm not happy with the performance, I can go ahead and take this further and fine tune this even more.